Hello students, this is Miss Dalton. Today's notes are on continuous domain and range. We've already talked about domain and range as it applies to discrete graphs. The definition of discrete states this. Discrete graphs are points on a coordinate plane that have gaps, breaks, pauses, and or holes between them. So the ones that we have looked at is when we had a coordinate plane that had just points. So just random points on a coordinate plane. Okay, this is discrete data because they aren't connected. Each of the points they've got the gaps and the breaks and the pauses. Another example would be if we had that one that we looked at in class, which was called a step function. So that would be considered a discrete function also because of the breaks that are in the lines. Okay, well with this lesson we're going to look at what's called continuous. And continuous are unbroken, it's an unbroken line or curve with no gaps or breaks. So that's what most of our graphs look like. And it would just be continuous, and it's just what how the word sounds. Continuous means it starts and it just is a continuous curve or line. Okay, it doesn't have to go on forever on either side. It could be a segment that that stops and ends, but bottom line, from the beginning to the end, there are no breaks or gaps between it. Okay, so in this lesson we're going to look at domain and range. Well, domain, we've already talked about. Domain are all of the x values. So something that you can remember when you're looking at continuous is when you write the domain, you're going to read it from left to right. Okay? Range are all of the y values. Well, remember the y-axis goes up and down, so when you do this, you're going to read it from the bottom to the top, and that's what the B and the T stands for. So you can write that into your notes, that this is bottom to the top. Alright, so let's look at some examples. Okay, in example 1, we have a continuous graph and it has two endpoints. This endpoint right here is a closed endpoint. That means that that point is included. And this is an open endpoint, meaning that that point is not included. So when we write the domain, we're looking at just the x values that are included. Well, if I was to write the ordered pair for this point right here, it would be negative 1, 2, 3, 4, 5, 6, negative 7, and it would be negative 3. So negative 7, negative 3 is what this point represents, and this point up here is going to be positive 1, 2, 3, 4, positive 5, positive 1. Well, if I was to look at just my domain, which are my x values, okay, so in parentheses I'm going to say that's my x values. Well, my x values are going from left to right. It's going to be from this x value, which was negative 7, all the way over to this x value, which was positive 5. Okay, so if you look at it, it's all of these x values in between because this graph has no gaps or holes, so it's including every single x value that's in between here. Okay? Sorry about that. That was my clock dinging. In order to write this, what we're going to do is we're going to write what's called inequality notation, which means we're going to write those x values as an inequality. Well, to do that, we would say that it's all of the x values that are between those two numbers, which is negative 7 and positive 5. Well, we're going to do the curly parentheses, And how we write a between statement is we will put the lowest value, which was -7. We'll put the highest value, 5. And it's all of the x values that are between those two numbers. So we put our x in the middle. And then we're going to put a less than on either side of that x. And basically what this is saying is that it's all of the x values that are greater than the -7, because I'm reading it backwards, and it's all of the x values that are less than 5. Now I haven't gone ahead and put my lines in yet, so let's do that. At -7, that is included, or that x value is included, so let's make that a less than or equal to. And then on the 5, that is not included, so that's going to just be a less than. And then we're going to close it with the curly parentheses. Okay, for range, we're going to use red for range. Well, for range, it's all of the y values. So if you look at this value here, that is the lowest y value that is included. And it goes all the way up to this value here. So it's all of these y values here. So that would be from -3 up to +1. So again, when you write your range, it is your y values. So you're going to put the curly parenthesis, you're going to put the lowest number, which is -3. You're going to put y in the middle, and then the highest number, which was 1. And then all you have to do is put in your inequality symbols. Now, these will always be less than, always. When you have a between statement, you always use less than. But now we just have to decide, do we need an or equal to on both of them? Well, if you look at -3, -3 is included because that's a solid circle, so that's going to have a line under it. But 1 is not included. There's an open circle, so that is not going to have a line under it. And so now you've written domain and range. Okay, so now let's look at example 2. And this represents a continuous graph with only one endpoint, and so it continues on forever in the other direction. So if we're going to look at domain first, and for domain, remember we're using that is our x values, so we're looking from the left side to the right side. Well, on the left side, it's starting over here at 0, 0. And on the right side, it is going on forever on the right side. And so how we look at that is it's going to be all of the x values that are on this side, okay, because it's going to keep on going forever. So if we were to write that as an inequality, that would be all of the x values that are greater than 0. But because 0 has a closed circle, then it would be greater than or equal to, so we'd put the line under it. Okay, so when you have one arrow, that means it's going to go on forever in one direction. So you just have to decide, is it greater than a number or is it less than a number? Well, if it's going to the right, it's going to be greater than. Going to the left, it's less than. Now, when you're looking at the range, now you're looking at the y values. So that is from the bottom to the top. So at the bottom, that's at 0. But if you look at your graph, it's everything above that 0. So it's everything up here. Because that's going to continue going on forever, and so it's going to it's going to keep on going up, 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 up. Well, because it's going up, then our range, of course, is going to be our y values that are greater than or equal to 0. If it was going below that 0, well, then we would use less than or equal to. Okay, so when you have a continuous graph going in one direction, you're just going to have either less than or greater than. Okay, example 3 has a continuous graph and it has 2 arrows. So this is what you do when you have a continuous graph that has 2 arrows. To do the domain, again, we're looking at the x values, which you would look at the graph from left to right. Well, on the left side of my graph, I have an arrow. That means it's going to go on forever on the left side. On the right side, I have an arrow also. That means it's going to go on, keep going in the right direction forever. So what you're going to write down when it goes forever on both sides is you're going to do your little curly parentheses and you're going to just say all real numbers. And then close it. Okay, so what that means is that the domain is all of the real numbers for x. Now look at the range. So the range, again, are your y values, and that's going from bottom to top. Okay, well, if you look at the bottom of your graph, it is right here at 0. And if you look at the top of your graph, it goes on forever. So it's all of the y values on this side of 0. So is that less than or is it greater than? Well, it's above, so that represents all the y values that are greater than or equal to 0. Now, why did I put the line under it? Because it has a point that is at 0, because that comes down and comes back up. So that point is included. So I have to put the line under it. Okay? All right, guys, that's it for tonight's lesson. Tomorrow we're going to work on this in class.